TPA3255, the winner board. Finally, I found a board what satisfies me after some rework in all aspects. It is evolution of this first generation, the same company, evolution of SAMP 200. And if you look at the board, we have different type of inductors, and those inductors are better and the wire is thicker. We have better output filter capacitors, and this is important for total harmonic distortions, so this output filter quality determines largely final total harmonic distortions what we will get. They use the same principle. There is plus minus voltage for operational amplifiers. When you have plus minus 12 volts for operational amplifiers, they really shine. Any operational amplifier then performs, so that there is no any worry about input signal amplification and other stuff. And also they added 12 volts for fan. We need fan to operate at maximum power. When you put 48 volts, the idle consumption is 10 watts, and those 10 watts should go somewhere. And when you play at the maximum loudness, then additional 10 watts you should dissipate. Then without fan it's not possible. Then you should reduce supply voltage to 36 volts. But I want to run it at the maximum power, so those 12 volts for a fan are important. And what they are writing the power supply interface of the fan for pre-stage Bluetooth. I tested, and this quality of this output voltage is not sufficient to run a good high quality Bluetooth. You get some extra noise, yeah, minimum, but still it's not anymore that maximum you can squeeze out this of this board. Normally you can run only fan. It's 12 volts, 300 milliamps. I will think what to do about Bluetooth. It would be nice to put some good board inside, and then this amplifier will shine, and also you can use it as a Bluetooth amplifier and get out to 150 watts. Fantastic, if you can. There are two chips. As for a previous board, those are set in parallel bridged configuration. It is good version because you can run up to 2 ohms load, and for some tough speakers it may be important. Anyway, we are not going to run 2 ohm speakers. We are going to run 4 ohm speakers and have some capability that this board will perform at any changes of the load. They mentioned that there is good capacitors, electrolytic capacitors, and they are, but input stage is made in a way that they don't go through electrolytic capacitors. Since we have a dual voltage plus minus 12 volts power supply, then there is a null at the input, and there is only resistive components. There is no capacitor, and if you look at the meander and low frequencies, this meander really performs better than when you have such capacitors at input. Power switch, that's good, because with power switch you can put the board in idle, and it is convenient. They mentioned Korean large volume film capacitor. I measured. It's really good capacitor with a very low serial resistance. It's we can trust that advertisement. Yes, this capacitor is really good. And also the manufacturer mentioned that there are good inductors, and those are really good inductors. I tested, absolutely perfect. Does this board has a drawback? Yes, they have. And the way how thermal solution is done is not good. I had suspicious, and I tested the board to the limit, and first board give up with a blast. So this chip doesn't have a good thermal contact with heatsink, and we should rework it. It's easy to rework, but this is the biggest mistake what is done with this board. With all components, everything is good, and it sounds really good. But thermally it's not okay. Not okay. Let's look at the board more in details. How can we fix this thermal issue? Okay, and let's analyze that thermal issue what we have, and I will use that damaged board as example. Now first we have great nice heatsink. large enough. If we put in a vertical position and provide some natural air convection, we can use without a fan, using it vertically. For example, if you put on a wall, you don't need a fan. But if you put it in a flat way, in a box, then definitely you need, because there is no airflow. All heat is accumulating inside the box, and then we have an issues. When you are making such type of solutions, it's very important how you make pressure and flatness to the chipset between heatsink and the chip, with the thermal grease in between them. And here it is done in a way that designers are using spring load of PCB board and tightening with the screws. For this solution, we are missing spacers. They should be spacers. I would say 500 micron spacers, and then that the spring load will be excellent. But in that solution, we are missing them. That means those screws are relatively loose, and when you're running at high power, there is a vibration, and then this is not a reliable solution. Earlier or later, you will get problems. And there should be certain precise force, I would say, for electronic guys and for computer guys, 2/3 at your maximum, what you can squeeze fingers. This should be kind of force what you put between, or a spring load what you put between that heatsink and chip, and you can achieve it if you put proper spacers here. But how it is done in this particular case, let's look at it. There's 3 screws, and those screws are tightened, probably with calibrated screwdriver force, but anyway. But those are relatively loose, and those are loose, and those are not tight enough to really serve for a long term. And here was the problem. You can see there the thermal grease, everything was fine, but the chip gave up with a blast. How to fix it? Actually, it's very easy to fix. There are determined thickness of chip. It's 1 millimeter, precisely 1 millimeter. And if you put some 500 micron spacer, and you can do it with, this is industrially provided thermal spacer for TO220 package. And you should drill a little bit larger hole, about 4 millimeters. By design, it's 3.5, and they fit exactly, and you have a small space, those 500 microns. And if you put a thermal pad or thermal paste, then you can tighten your design with the 3 millimeter screws, and you can tighten them really tight, still keeping that predefined spring load for a chip. And how you can test that your thermal solution is good? If you do everything right, then there is no hot space beneath PCB board. All hot is going up to the heatsink. And when you have insufficient this thermal contact, then chip becoming very hot, and you can test it by that. When I burned the chip, I was kind of casual. I thought that from the factory, this thermal is okay, but it wasn't. And I haven't checked how hot are surface beneath it. I knew it, but sometimes when you knew things but too confident about something, then you run into trouble. That was my case. And when you put everything together with those spacers, then you can tighten screws really tight, still keeping predefined spring load mechanism. And this is reliable solution. I tested it. Is so good. And especially if you have a good thermal pad, 500 microns or 0.5 millimeter thick thermal pads, and those are produced in a large quantities, and you can buy them. They are even good, some 20 watts per meter efficiency, so you can make excellent thermal solution. And with a small fan you can run it at a maximum power infinite time. Now for 48 volt power supply you need a small fan, but it is easy to implement, and then this board, probably only solution what I have seen, is capable really run to maximum capacity what TPA3255 has. That means you on a 4 ohms you can get clean 250 watts, absolutely excellent power per channel. And could you imagine 250 watts stereo amplifier? It's a monster. It's a monster. And of course your quality largely depends on a power supply. And in some sense, TPA3255 wins the market because we can use industrial power supply. I found one really good industrial power supply. There are also specialized power supplies from AliExpress dedicated for TPA3255, even gun-fed power supplies. But here is a mainstream, and this power supply from Meanwell, it's a medical grade LOP 300 power supply, and it can do for 3 seconds 450 watts by specs, and this is good manufacture. That means they can really do. And this is a resonance type power supply. It's low noise resonance type power supply with PFC and very low idle consumption, 0.5 watts. That means if you combine mute switch, you don't need to switch off power supply, because it will go in this burst mode and consume only 0.5 watts. You don't need a special standby power. You can build very good power amplifier on this combination. And what is also good with that, without fan, this power supply has been built to provide 200 watts continuous power. Since music has a crest factor of 8 to sine wave, that means thermally it can provide 1.5 kilowatts, and in reality when you really run at full power, those 2 times 250 watts, it's barely warm. So that means you have small size, it's proper thermal design for audio amplifier, and this resonant switching mode power supply architecture is excellent for that board. So we have a good combination. This is one reason why TPA3255 is really ruling this 100 watt and around amplifier market currently. You can get so good quality. When you fix minor issue with the thermal management, then you can build really good amplifier. And let's take a basic measurements. Okay, switching amplifier on, and you can see on 1 kilohertz perfect signal, about 10 watts output, and we will do basic measurements. And first let's check how output filter has been tuned. We will use sweep from 20 Hz to 20 kilohertz. Here is the sweep, and for 8 ohms you can see there is a slight add-on, I would say about 1 decibel maybe, which is good. And how about the 4 ohms? And for 4 ohms it's perfectly flat, I would say. I like that this board, which is 2 ohms rated, has been tuned for 4 ohms, because it's logical. Once you are 2 ohms rated amplifier, it would be reasonable to tune it for 4 ohms and really good frequency characteristics. And let's check square wave for 50 Hz. It's excellent. And for 20 Hz, it's perfect. Once we have this plus minus 12 volts power supply for preamplifier, we don't need input capacitor, and then we have this great option to have perfection on low frequencies. And let's look at the ramp, and the ramp is great down to 20 Hz on 50 Hz, the linearity is perfect. So this board has good engineering add-ons, and it reflects in a measurement. Really good results. And last thing to measure, it's about the maximum power what this board can deliver using 48 volt power supply, and using this medical grade Meanwell power supply LOP300, which by documentation is rated that it can handle 450 watts for a short term for about 3 seconds, provide that energy. It's a 450 watt rated power supply, and let's check could it really do that. Here we have 1 kilohertz, and let's take a no load condition. Let's put maximum output power. Let's set maximum output power below the clipping, and it is, no, let's set to the maximum because I want to test the power supply capability. And this at 32 output RMS output volts, it's 250 watts. Here we have some distortions around 1%. Okay, how about 8 ohms? I will put it short term for 8 ohms. No problem, with confidence, no load. 8 ohm load for both channels. And how about 4 ohms? We know that this power supply is capable on short term 450 watts, and we are providing currently about 500 watts. Yeah, it drops to 30, but it is not switching off, it's just dropping a little bit. So if you reduce it to the 220, yeah, 220. And what is good with industrial power supplies from good manufacturers? They're really keeping promises. They promised 450 watts and they can deliver those 450 watts. And I would say that together with this great large capacitor with low zero resistance, the system easy can do this to those 250 watts, because this capacitor will add necessary 20 watts what we need for a peaks for a music. So we will have a confident 250 watt amplification system together with good power supply. And we really need a good power supply. We need a 48 volts 10 amps rated power supply to run with a confidence all possible scenarios, and this small power supply can do that. Could you imagine? I'm really happy with the results. Those results are confident, and if you provide such system, it will be 250 watt rated stereo amplifier, high quality stereo amplifier in that size. Unbelievable. And summary. No, here is device what we measured. It's second board. I was lazy to fix the first one because the board price is so low that it's not worth the time what you spend fixing something which is totally burned. I will do it in the next summer probably. But highlights and lowlights. And let's start with the lowlights first. First lowlight, it is must to fix that thermal issue, how heatsink has been fixed to the board, that you have this constant pressure and effective heating. It's must, otherwise you can't work. Second one, promised nice 12 volts. Those are not clean. Those are converters, and there should be additional filters to clean it, especially when you put it together with fan. Fan is a noisy element, and I personally would like to have two separated outputs. Yes, it's more components, but anyway, it should be integrated in that for a fan we have one output. It's well separated and filtered from the rest of components, and then have another 12 volts for a, let's say, preamp. Initially I thought that I can integrate that great Bluetooth board. It was meant to be here. It was pretty relatively difficult to implement this board because it has a fixed connector. There are better boards with a flexible antenna cable. But anyway, unfortunately it was not possible. Those output capacity was rated to 12 volts and 300 milliamps, but I think 100 is a max what you can really use it. And it is noisy. You should put additional filtration elements and it become complicated. So in fact it is better to make just an amplifier. So maybe later on I will work on it and try to find out how can we implement both, but definitely one thing is clear, that we need another down converter for fan, and there are down converters with a enable pin. Then we can use those 12 volts to enable that pin and have all automation. But it become complicated, and once it doesn't work, so I would say this is a low light. Now about the highlights. The first, quality is fantastic. Yeah, audio quality is fantastic. I managed to use mainstream 50mm fan and reduce its voltage to 9 volts, and then it become almost inaudible from 50 centimeters, and that's good. Also good, I would say that pretty good was that small switch. You can add a small switch and then you have option to switch it on and off, and combine it with that meanwhile power supply. It delivers fantastic audio quality. I was surprised, really surprised. How about the Bluetooth? Now you can keep it external. Because largely your quality, Bluetooth quality, that final percentage of Bluetooth quality largely depends on the power supply quality. If you provide good USB power supply, then it performs excellent, and it has automation to switch between in and out, and then you can leave it as it is. Also you can run it from battery and some power bank. With some power bank you can run it for a month. So there are plenty of flexible solutions with the Bluetooth, and in some sense there's no reason to integrate Bluetooth in amplifier, because this technology is developing so fast. There's new and new type of Bluetooths, and there's also LDAC Bluetooth, and there is a next generation high definition Bluetooth will be, and who knows, maybe there will be even not only 2.4 gigahertz but also 5.8 gigahertz Bluetooth. Who knows what will be in the future, and then we keep a flexibility to use it as a separate item. I personally like idea about small power bank and Bluetooth. Then it's become universal. Due to the Bluetooth I made the box larger, but at some point I like it even more. Will I make a product out of it? No, it's very hard to make a product. And there is one reason. Because Ice Power has TPA3255 fully integrated board at industrial grade. And it's impossible to beat this board, because power supply is integrated, everything is small, you have great toroidal inductors, even and filter is better than here. It's more sophisticated and has a great linearity, and it sounds neutral and perfect. I made a kit for that. Strictly talking, the final design, if you buy in retail, all components will be about 30% higher than building such board, but here you need the time, here you don't need it. It has a balanced inputs, by design, and balanced inputs you can use with such adapters to make them RCA compatible. Overall, such design is much smaller when combined power supply and amplifier board. A significant size difference. And here you have a warranties, you have a continuity in time, because industrial boards will be produced for many years. So people ask, are you going to make a kit or something? No way. This board is killing all businesses. Nevertheless, there are plenty of China designed boards in the market. I'm still wondering why people buying them. That there is excellent industrial board. All thermal things are made at perfection. Large heatsink beneath, and then this thermal dissipation is large. You don't need a fan. It's also using 42 volt power supply, not going to absolute maximum, that this heat dissipation is perfect. How do they sound? They sound equal. Here you can get a little bit more power, but you need a fan. Money wise, in case we are not counting our time, then you have some small benefit about it. 30, maybe 50 euros, but in reality, I would say this is cheaper and more reliable. So after some hesitation, I built only this kit for that board. This board is available in Sound Import, in Parts Express. Everywhere you have warranties, you have possibility to buy in your local country, and I'm selling just a kit. Yeah, I have on my site also finished amplifiers, but I think you can benefit buying a board separately from enclosure and then build whatever you want. It is perfect match to audio interfaces, some small mixers, some preamplifiers. Normally, volume regulator should be introduced in preamplifier or in Bluetooth preamplifier, doesn't matter. But those who doesn't have, here is very good headphone preamp available on Amazon, on AliExpress, on eBay, and then you can have a volume regulator as well for even for 4 amplifiers. Yeah, 1 input and 4 outputs. You can make some crazy thing out of it. Costs below 20 euros, I think. But anyway, there are so many solutions. What is saying that for those boards, yes, you can implement in different place in different way, but there is industrial board close to excellence. And when I talk about the 12 volt quality, then here you have plus minus 17 volts, which you can stabilize with a parametric stabilizer and get very good or correct preamplifier power. And then you can integrate Bluetooth in it, and this Bluetooth will shine. So I'm happy with this design, really happy with the board, but this is better one. Yeah, it costs a bit more, but size, easy to integrate, services, many things. But for anyone who wants to build something, which is great, and here you can put a volume, passive volume regulator in front of it. It's not bad. It's not bad. At some sense, this split power supply and an amplifier board concept, what comes from my China colleagues, also has a place to live. For those who hate fans, could you use it without fan? You can't use it on a vertical configuration with 48 volt power supply. You can't. But if you put it like that on a wall or on some special feeds, then yes, you can. In case you rework mechanics to meet that thermal contact, yeah, then you can. Will they operate at a high temperature? Yes. the system will operate, but you will always be thinking, is it okay or is it dangerous? Yeah, and it's better to put everything according to the book, I would say. So currently this is a winner among China developed boards by quality. Yeah, this is the best one. Really sounds amazing. It has good components. It's easy to implement volume regulator. It's easy to implement on-off switch, and if you combine it with a good power supply, then you will have great amplifier. Would I recommend this board? Definitely. Want to build something great? Yes. But as I mentioned, in my opinion, ice power board is better solution. Yes, more expensive, but better one.